But it's also good for you because I'm in a position to actually share some of the interesting lessons we learned through the period of our hypergrowth. And a couple months ago, I was thinking how to name this presentation. And the first one that came to mind was 0 to 60 R analogy, and at the time we had about 60 million numbers. So LinkedIn going 0 to 60. So what do I know? By the end of the year, we're going to have 9 million numbers as a minimum. So how does research? And actually, if you go further, we think that by our estimation, we're going to have 500 million professionals at some point in time. So that's the goal. No real agenda except to do what Tia asked us to do, which is to be brutally honest about lessons we've learned. I would also like to tell you how LinkedIn team thinks about scalability, and I hope to have some time to answer questions. By the way, I don't know if you guys followed TechCrunch drop yesterday. LinkedIn launched a couple of exciting products there, namely LinkedIn Signal, and so much so that David Kirkpatrick of the Dailies, the former reporter of Fortune magazine, who wrote the Facebook Effect, movie coming out tomorrow. Perfect timing. There was an article yesterday called The Other Social Network. Well, Google it if you get bored. But for now, scalability. So we all think scalability matters, we all care about scalability, that's like a here. The truth is we actually have no idea. And to illustrate the point, let's look at this chart. This is a number of web page index in million since 1995. 3,000x. So how does this graph look to you? It's going to accelerate into the right side. And then just web pages indexed. Some other pieces of data. 24 hours of video a minute is being posted on YouTube. There are 200 million blogs. There's 50 million tweets, and it's probably outdated. It was 50 million tweets a day about 6 months ago that's being tweeted. And about 1 billion content shares a day on Facebook. So these numbers are just too big to comprehend. And we have to, we as professionals, we have to build services that can make sense of all that data. And what do? Well, we throw hardware picture, which is very good for our vendors and workers. But at some point we have to stop and think what they're doing. So with that, let's go back into 2003. That's the time the LinkedIn site first launched on May 5th, 2003. Cinco de Mayo holiday, and Sunday called Cinco de Lincoln. And that should be familiar. This is you've seen this picture 100 times. This is canonical style of architecture. It basically has your web application with UI and VL layer. We also have our graph server, obviously, to keep track of our friend connections, and you have your core database. So that's what we started. And in all honesty, I don't know if the startup should start any different. Because until you know you have a workable idea, this is very simple. So this is the architecture of Circuit 2005, 2006, about the time I joined the company. When I joined the company, we had 5 million members. So what we started with some problems of scale. Because 5 million members is a little bit more than nothing. So the first place we did the bottleneck was the core database. And we invented a technology called the data bus internal that allows essentially a replication log that allows the replicated data in the database to derivative data stores. So that was Oracle, that was MySQL. And we also split out graph server from our search. Users kept coming in, obviously users. And at some point we had to again stop and think of how we can scale that other problem. So, service area architecture was very low at the time, and we looked at that obviously. The promise was that each service, we basically split the system into a set of services. Each service can scale independently, which is good. You can do parallel development, so developers can work in parallel on different services. If they can be isolated from each other, so the email doesn't bring down the profile service. And you can ostensibly have graceful degradation of services, right? So we went on that route, and that's architecture of LinkedIn pretty much 2007 going forward. Now it is a little bit more complex than that, but basic layers are there. So the system split into services. You have the search, you have the profile service, you have the communication service, 275 in total. You have multiple web applications. You have the graph server, different architecture, of course, than it was before, and you have multiple databases. We still replicate some of them, some of them. That's the basics of it. So what we learned, or started to learn through that process. So we obviously have to increase complexity. 275 services to maintain, and growing every day. With every release, it's not nothing. We have diminished integrity. And what I mean by diminished integrity, you can have a mailbox that has no profile associated with it. You have a profile, basically orphan data in the system, inconsistent data in the system. And think about it the next time you have an argument about eventual consistency versus non-consistency with a single data store, right? Think of the overall system, how that can be inconsistent. Obviously, you have higher costs because you simply need more hardware because the system doesn't load balance itself as well. And you have unintended side effects, right? I mentioned unintended side effects, right? Which we're going to discuss shortly. So, top unintended side effects, that's very interesting. So, exhibit number one is a simple situation. You have three services. Service 1 is calling service 2, is calling service 3. Both service 2 and service 3 normally in numbers calculation. Take say just for easy calculation here. Each take 100 milliseconds. You have your client, RPC client that basically, has 500 milliseconds timeout because services can get closed and you need a timeout. And it has some retries. So everything works. But what can happen in this situation is that there is something called service 2, that service 2 executes called service 3, and that is overloaded or somehow responds slower than usual, but say goes over the timeout threshold. So what happens here then, service 2 will call service 3, service 1 will timeout anytime retry, service 2 will do the same thing. At the end of the day, user gets nothing after a second, and you burn about 3 seconds of your processing time in your service system. Pretty retarded. Actually, with the real situation, we have a network update service, which is our new system in the moment. Calling LinkedIn answer service, we have a question that is called cloud, our graph server, to filter it by degree distance. And that's pretty computationally intensive. And that was before we had garbage collection issues with the graph server at the time. So that it could basically exhibit service variance. So I can tell you that we had this downtime twice. I decided to go down in a matter of 10 seconds. We just hard down on page, you'll get solved, users will get solved. So it's a real case scenario, don't do that. And now what we would like to use for that is an ATM machine. You go to the ATM machine, you put your card in, you withdraw money from your checking account, money gets withdrawn from your checking account. You expect cash, and you get the timeout. So you basically what you did, you burn the CPU cycles for whatever resources you're using in the back, yet the user got nothing. And it would have not been funny if I actually did run that in that exact situation with the real ATM machine. Exhibit number 2, connection pools. So you have many services, you have many connection pools in the system, whether it's JTC connection pools, whether it's HTTP connection pools. And of course, all those pools have industry standard rate of 20 connections that people rarely think about it. So what it can cause is because of bottlenecks down the line, even if systems properly scale, even if you have enough hardware capacity, you can introduce unintended bottlenecks in the system. That also happened to us until we started to think about it. Let's look at some more use cases. That's the LinkedIn homepage, should look familiar. And what you have here, you have multiple components. Like you have the Chrome that actually can exhibit some counts at the top. You have the network update stream. You have the inbox. You have people you know module. You have who views my profile. You have obviously omnipresent ad, which is very important. And you would like to load as fast as possible, obviously. So in a normal case, you would call multiple services to compute all the data that you need. And unlike in some other places, with social networks, that data is very personalized. It's very specific to you. So let's say you call those services, and each takes 10 milliseconds. By the end of the day, you basically you can respond in 50 milliseconds. You get numbers of each on that particular thread. You can process 20 requests per second. Now you can improve that, which we do, and you can fill the hardware, right? So then you can drop your latency to 20 milliseconds. Now, what you have to think here about is that you're actually putting more load on your back. Because users, first of all, you're removing essentially natural throttling of the browser. So the user may click on something much faster than you anticipated. You have those, although you process the same number of requests, or maybe slightly more users act on what you're doing, but you're putting burst load on your backend, so you just need to make sure that you can handle it. another use case should be very familiar. It's LinkedIn inbox. Messages sorted in descending order. Essentially, they just your mailbox, 20 per page. So let's look at, people don't think about it with all the layers we've invented in our infrastructure. What's the worst case scenario that could be? The worst case scenario that could be that each message is its own separate block on disk, right? So let's just calculate the web time. So you can have 8 milliseconds seek time, let's say 2 milliseconds for something else. Your worst case scenario, you'll spend 200 milliseconds to display 20 messages. That's not ideal. And people don't think about it on the caching layers because, majority of data sets are simple and they can be cached. That's not the case at a large scale. So what you can do here, you can make sure your data is partitioned in the order as it being presented to the user. So you go from 200 milliseconds to 10 milliseconds right there, just by organizing the data on disk. Let's look at another use case, that's search page. Right? So you search for something, the software engineer, in this case. You get a set of results. You need to show, you see that the search results are decorated with some profile data, so you need to do that. And to do that, you probably not as lucky as in the inbox case, because you'll likely be random once, right? Again, 200 milliseconds. So what did we hear? You could fetch data in parallel, and systems like Baltimore are very good at that. That's a typical use case. One could also say that we could cache the data, or there's a cache there as well. So if we cache something, let's say typical cache logic, we need to get 100 profiles. We try to get 100 files from cache. 100 profiles are on cache. We turn them 2 milliseconds, basically an all. Well, not exactly an all, but pretty good performance. Let's say 98 profiles are in the cache in 2.5. So what happens? We have to go into the database, get it back, put it into the cache, and return it back to the user. So your basically your response time goes up from 2 milliseconds to 22 milliseconds. Something like that. 14 standard deviations. That's what your service will do. So think about that as well. So what we've learned is actually well-known 8 fallacies of distributed computing are very true. And let me go through them and see what we get and what isn't get. So the network is reliable. It is not. I've yet to see a load balancer, hardware load balancer that works all the time. I've not seen one. And to my knowledge, nobody has seen one. Latency is 0. We know it's not 0. Bandwidth is infinite. Bandwidth is absolutely not infinite. Even with all the monitoring, and it's shameful way to say that, but we hit bandwidth limitation twice. We physically run out of bandwidth on the network twice. And network is secure. Haven't seen that problem. Typically, you should rely on being secure. It has been secure in our case. The topology doesn't change. Obviously, changes all the time. New hardware arrives, old hardware gets decommissioned. There's one administrator. Obviously, that's another fallacy. Sometimes you don't administer at all. And transport cost is 0. It's not 0. It's actually piled up pretty fast. And you have to think about the topology in the data center where your services relative to your switches are. And network is homogeneous. Again, it's not homogeneous because you just don't randomly replace everything at once with the same pieces of infrastructure. All right, so service-oriented architecture has benefits, as you learned. Yes, some things can be accomplished. Has caveats, many of which being diminished data integrity. And probably not applicable to proof of concept type of situations. So the main takeaway is actually handled with care. All right. So the next thing I would like to talk about is pillars of generic infrastructure. How things can we see a basic website infrastructure. So the most important piece, and they're probably in priority order, is the data lake. That's the most important piece of infrastructure you can think of. And there are many choices out there. And what questions you want to ask yourself is what's your read-to-write ratio? Is it your system primarily reads or there's a lot of writes? Do we need range queries or you don't need range queries? If you don't need range queries, again, p-value pairs start with all the most wrong. If If you need range queries, then you have to think along the lines of Cassandra as a data social prose, right? Or something even relational. What consistency guarantees do you want to have in the system? Can it be easy to do reader pair? You should be able to do reader pair, as we talked about it, for other reasons. Do you have derived data in caches? And normally, by derived data in caches, what I mean is, do you have a search index next to the database? Do you need some kind of synthetic cache? Normally you do. How do you do replication to support multiple data centers? And last but not least is how do you do ETL? Because you do need that data for my processing. So the next part is really the log. And whether it's a virtual log implemented by the data layer or a real log, you need it. There's a simple use case. Let's examine the profile. So you have a profile database, your profile LinkedIn user goes and updates the profiles, it changes the position. So we want to be able to index that in a search index. We also want to be able to cache them. So you don't have to hit the DB. So you need to be able to know what changed in the database effectively and be able to construct these derived stores in a manner that is consistent with the database. Because you obviously don't want to do a search inside the database. You want a nice search service. The third component, you need queuing. You can't expect everything to do the same. So this is a snippet of LinkedIn communication architecture with the invitations that being sent. And of course, that's also done asynchronously. So the email that you see at the end of the day in the mailbox gets constructed progressively and has Chrome put on it. Obviously, you don't wait for any of that to happen. So the queuing is a very important part of the generic infrastructure. And there are others. The search is one, so you gotta figure out what search technology you're using. You need to figure out what you use in batch processing, because that's important if you want to implement features like who viewed my profile, for example, or just general business analytics. The RPC layer is important, whether it's REST, basically by RPC layer I mean how they different components of the system call each other. Deployment, how the services can deploy manually, and monitoring. So those are generic pieces of infrastructure that pretty much any website of a decent size should have. Now, in a social network, there are a couple more. What makes the core piece of infrastructure of the social network is the profile, because the identity is the most important piece that you can have in a social network. The graph, basically your connections, your different types of associations that we have, whether it's groups, whether it's ad hoc groups, work groups. That's what you need to have. The string, the environment of the network. We call it network update string, Facebook calls it newsfeed, but that's basically what makes the network happen. What makes a social network see that the main principle, but the lowest one PC monkey do, right? That's what implements it. You always need to be able to send emails to users, whether it's digest emails, one-to-one communications. People expect search, they just give them. And more and more, you have to have the capabilities to build intelligent features on top of the network. So this is what we use. And again, some of those technologies we started with, and we are finding replacement for them. Some of them are newer. So that's a collection of things. LinkedIn is 99% pure Java. Probably a little bit less if you count scaling, but it's a mix of Java today. For the basic plumbing, we use extensively Spring and Spring Remoting, which we are trying to get away from, replacing with different serialization. Tomcat and JD for containers, and Keeper for managing different components of the network. As I mentioned, the data bus, we have a couple of low-level components. One of them, which is one system called Kafka. Something, again, Google it. Memcache, we use ActiveMQ, which served us well, but probably not something we'll continue to use. Oracle remains in many places as a main database. Voldemort getting more and more. Basically, anytime we need to do key value Oracle is Voldemort. As we've seen with various extensions of those. The web framework is our proprietary web framework called Frontier that does this assembly of content and power by UI for the JavaScript library. We do have a couple of components written in different languages, namely Ruby on Rails. Some corporate applications are written in Ruby. Some applications are written in Ruby on Rails. There's one application written in JRuby. And different various tools. We have a couple of proprietary tools. One of them is a Glue framework that is used to deploy our components into the network. Some of them are open source. So that's the basic. A lot of monitoring in the system at all levels, and just an example of various drafts. This one's particularly managing different components of network update system. There's another way to manage performance as well. This is my box. Before updating this picture, as you see at the real page. And I've looked at these slides, so we are hiring, as the must say we are not done. We are going to be at 90 million members probably in a month or so. We are going to 500. So there's a lot of industry problems to be solved. And at this point, actually, I would purposely like to make this presentation fairly short to be able to answer questions, because I know I'll be able to cover everything about LinkedIn in 50 minutes presentation, and I actually would like you to be active and ask questions, and happy to answer questions about LinkedIn engineering and the company in general. Please. Yes?
You mentioned one point caching profiles. How do you all go about determining the person's in this room? If I change my status, it might affect 5 people who serve their profiles. So how do you figure out what profiles you're going to query?
So what we're trying to maintain is read off the right consistency. So if you change your profile, you will see your most recent changes. Other people may not necessarily see your recent changes and you get replicated.
So it looks like at certain, in a couple of graphs, it looks like your data bus, right?
Yes.
Monitoring updates from your database is actually invalidating cache and updating cache.
Correct.
How do you monitor that, and have you had any issues where it's too far behind, and then you know how do you monitor its ability to do that and keep up?
So we do monitor that. We have multiple caches, so we have multiple replicas. So it's not like there's just one replica.
Right.
It did get behind. It could get behind, but you know, as with anything in any system that relies on replication. So what's going to happen is users will go to the main database and they'll see that there are changes. The people who actually own the data, like you own your profile, and somebody else, your profile comes up in the search results and maybe step. So it will just read it from the rest. Yes?
So you have an expected lag of data updates from data centers. You just expect that there'll be a lag when you send the same user to the same data center so that they will see their own.
Correct. Yeah. Yes?
You said that you guys use Ruby and on Rails, but you also use JRuby. Do you
Right.
only use JRuby with Rails, or do you actually use Ruby as well? And
So
if
we actually have a couple of applications, open source applications. The one you can see on the homepage called the Twitter application that actually, and there's events application also. Those are written in Ruby on Rails. They actually hosted in a different data center. And that's for our first kind of experimentation with Ruby on Rails framework. Now, we kind of settled on JRuby going forward because it's much more convenient since the rest of the stack is in Java. It's just much better operation.
have you seen better performance and better memory behavior with JRuby versus Ruby on Rails, or do you have any?
I don't think, no, we haven't seen it yet, but I think our deployment of that is not at a scale where those problems will exhibit.
Sure.
So, I don't know.
So how do you handle deployments and maintaining consistency? Obviously, you've got a lot of code to deploy a lot of servers.
Right. So consistency. First, backwards compatibility. So all the services all the deployment scripts have to be backwards compatible, and that's obviously being tested. So if I'm calling profile, even if the profile service change, I should get the same data. If you're doing any grandfathering, that's probably done offline, and then those get rotated in. All software logic handles it. We actually never launched a feature that we don't A/B test. Essentially, any feature that gets launched on the site is launched to first the LinkedIn company group and 0.5% of the population, 1% of the population. So that's how we handle it. So, and we have a pretty significant deployment infrastructure that takes care of the sequence of deployments, completely automated, and knows what to do on the program.
How do you test code changes in an environment that doesn't exactly replicate the load that you see in production? Where do you have one?
So we do have staging environment that doesn't exactly replicate what's in production, but it is pretty close. Is it 100%? No. Sometimes we read something and it doesn't work as intended. We either deal with it because it's a small A/B test, or we roll it back and replace it. I would say we're not a bank, so. We could deal with few issues unless those are very critical. But we do have staging environment. Yes?
How many developers in your team?
How many developers in total?
Yeah.
Well, it's been growing very fast. So when I started the company, we were 8 people, and now I believe we have about, actually, I think it's about 300.
300.
Yeah, about 300. 300 if you count engineering operations.
Yeah.
Yes.
How do you deal with the developer environments? How do you give a developer environment to work in?
So how do we deal with the environment? So developer environment is very interesting. It's so what you get in a engineering company, you get a Mac raw power with 24 gig of RAM, 8 core, dual monitor setup, plus a notebook to work from home. So what you can do, so you can bring a partial stack on your box. So you actually can bring services you mostly need in your box. If you can't, then there's staging, there's lab environments, and you can bring the full stack. But if you say you're working on a specific part, say you're working on a complete service, which is one of the heavier one because you need more. You bring all these services up you need to work in the part. And of course, they tune to develop environments. You don't start them with in production configuration. It was interesting when I started, I could actually bring the time and put on stack on this notebook. Yes? More questions?
Do you get a lot of information said about interaction between Zookeeper and Voldemort?
There's no interaction between Zookeeper and Voldemort. So we use Zookeeper in 2 places. One is, actually more than 2 places. So one place is we use it to manage our deployment. So we use it as a mechanism to maintain consistency across our deployment. The second place we use Zookeeper is, I mentioned the log replication system. So we have a system that propagates events. So we manage it we use it to manage clusters of servers that are being brought down. So the log is one, the ID generator is another one. We have a system similar to Snowflake that Triller uses that generates incrementing sequential IDs for our data. So that's managed. One question? All right.
So how do you deal with creating data sets, realistic data sets for development?
So we have, thank God, we've done it from the very beginning. So we have what we call celebrity data set, where we actually have constructed a set of networks that developers can load. It's fairly realistic. So we do have a lot of mod data sets that are available to developers to plugins. Yes.
In part of your talk, you
Yes, those are used separately. So Lucene is used to search. Basically, people search any other search in the site, mailbox search. Hadoop is used for label processing, so it's a batch environment where data gets transferred into from online standbys, and you do things like people you may know. You calculate network affinity. You do business analytics on it. You can just go and run them big queries against different logs to see how systems are performing. That's what we use Hadoop for. And Hadoop actually batch is, would like to stress that's a very important part of the system. And if I have to think back, Golden was specifically created to support that use case, to support the use case of quick import and export of the data out of Hadoop into production environment. Somebody had a question? Yes.
Does LinkedIn support a public API? And if you don't, do you see any challenges in supporting one in the future?
LinkedIn supports this partner program. There is the public API for LinkedIn. There are always challenges with public APIs. First of all, you can change them very easily. That restricts your flexibility, and that's why you normally don't expose everything you could expose. But we do support public APIs and plan to continue supporting them and enhancing them. Should be available right now anyway. I think it's part of the All right. Primarily to manage clusters of different servers. So we just know when servers up and servers down. So they are different. So it's essentially managing consistency. Yes?
How your platform changed? How has your platform changed over the last 5 or 6 years?
Platform in the sense of the software stack or the public API or?
Like the metal, the operating system, and
So it didn't actually change all that much. So we are using x86. We started using with some boxes initially. So we used x86 Solaris boxes all along. So now Linux gets introduced in the picture more and more. But generally, it didn't change that much. It was x86 Solaris and Java. And Mac, of course, actually when we started it was PowerPC Mac. Now it's x86 Mac. That's how it changed. Basic numbers. And now, of course, it may change on the hardware side. It may not. It depends where that merger is going. All right. I'm glad everybody's still awake. You can Google the other social network yet? No questions on that? All right then.